Okay. Now that we've done that, we can determine what our angle theta is. So our arc cos of 0.93. So I'll just write that right here. So step number 6, cos -1 of 0.93. And I get the arc cos, I get 21.3 degrees. And my power factor, I'll write that in here, which is 93%. All right, so far so good? All right. So now we've got our impedance. We can start finding out our other values here. We can find our current, and because it's a series circuit, we can find our currents here. So why don't we find our total current? We'll say step number 7, find IT, and IT would be equal to my E RMS, or my E total, divided by my I total, divided by my total impedance, so divided by Z. So I got an ERMS of 120 volts divided by 53.678 ohms, and a total amount of current in the circuit, I have 2.24 amps. So I'll write that in there. All right. Okay. Next step, let's look at our, we can write our currents in there. I'll write the currents in there. So. All right, now we can find our voltages. So let's go we'll start at our capacitive voltage. So step number 8. So step number 8, we'll find our voltage capacitive, which we say is our amperage capacitive times our reactance capacitive. So it'd be 2.24 amps times 132.63 ohms. So 2.24 times 132.63, I get 297.09 volts. So, you know, I can also put that into my triangle as well. So let's just take a look at what we've got here first. So let's take a look at our other voltages. So I've got capacitive 297.09. And then step 9, we'll find out what the voltage across the resistor is, which is just simply the amperage of the resistor times the value of the resistance of the resistor. So I got 2.24 times 50 ohms, which is 112 volts. So I'll write that in there. And then we'll say step number 10, we'll find the voltage across the inductor. So EL, and that would just be simply IL times my reactance of L. So 2.24 times 113.1. And I do that, I get 253.34 volts. Okay, so now we know we have a we know when we have a resistor voltage here that's 112 volts. Right? We know that. We know our RMS is 120 volts. We already know that. And when we're solving for our total voltage, it's actually a total voltage as a result of the reactance that's happening here. So we actually, what we do is we say that the total voltage, we have to add those vectors, but because those vectors are 180 degrees out of phase with each other, in other words, I would, really have something like this, where this would be EL and this would really be EC, they subtract from each other, right? So I'll just get rid of this. So then we say, okay, so step number 11 would be add my voltage phasor. So really what we're doing is just adding a negative value. So I would say, that my E reactive voltage is going to be equal, total is going to be equal to my E inductive voltage plus whatever my EXC voltage is, putting it in brackets, so making it a negative. So in other words, I would write that as 253.34, which is my inductive voltage, plus a negative value of 297.09, giving me a total voltage here of capacitive voltage or reactive voltage of 43.75. It's just a vector sum of the two, and since they're 180 degrees out of phase with each other, we just subtract them. So 43.75 volts we put right there. And we would consider, given the drawing, we would consider that to be capacitive. So again, if I was to use this, and I drew this little phasor, I'm not sure we need it, but I'll draw it here anyway. I say, okay, well, this would be EXL, this would be EXC, this would be ER, and also I, because they're in phase with each other. And I would say, okay, well, I have an EXL of 253.34, and I have an EXC of 297.09, then my value of total voltage, more capacitive, would be my EXT, which we said is equal to 43.75. And if I was to just bring that over like that, bring that like that, then we can see the relationship there like that. Okay, and that's how we get this. Okay. So far, so good? And you can always check, our RMS, you can always check to check to make sure that you're getting 120 volts to see that you're on track. So this is a somewhat more capacitive voltage. So the current is going to lead the voltage by 21 degrees in an ice, right? So it's more capacitive, right?